Hello guys and welcome to another episode of my Ability System series. In this one we will recreate the camera position and controls that can be found in most MMORPGs. And to start with, what we will do is create a new folder here called textures. Open that up and I will just very quickly import some that we will use in this episode. Okay, I imported those three textures here, goal, decal 1 to 3. The download link for that will be in the description, so make sure you also got those if you want to follow along with the series. And we will use those to display where our character is going to. When we click in our world, we will spawn a decal actor with one of these textures. Let's open up one, and here it is important that we uncheck sRGB because we will use alpha channels as individual masks. So uncheck this and we will do that for all of the other ones. Then we will create another folder called materials. In here we will right click, create a new material called m_goal decal. Then double click to open that up. In our materials settings, we will set the domain to deferred decal, blend mode to translucent, and the decal blend mode to emissive. When you've got that, you will only see the emissive color, opacity, and world position offset appearing here. Then what we will do is right click here and search for texture sample. Also, we will right click that, convert to parameter. Then we will give that a name, for example, texture, and we can select the texture for that. Any of the three you download will work fine. I will just use the goal 3. Okay, then I will hit 3 and left click to create a vector, and also right click, convert to parameter. This one we will simply call color, and I will give that a default value. So for the red I'll just type in 0.2, for green 0.16, and for the blue simply 1. So we've got a bright blue here, and then I will lower the alpha to 0.5 and hit OK. So we also got a color. After that you can hit 1 and left click to create a constant, which we will do now. We set the default value to 5, right click, convert to parameter, and we can call that something like emissive amount. So now we've got all of our parameters. Let's move them over to the left side a bit. And we will need to worry about our emissive color now. So what we will do is get the color pin of our texture, which is the upper one. Then drag off of that and search for multiply. We will multiply that with our color that we will multiply with the emissive amount before. Plug that in for the B, and then connect the multiply to the emissive color. And we can see that updating in our little preview window. Then we need to figure out the opacity, so we will drag off of the opacity pin, which is the lowest one of our texture, and we will multiply that by the opacity of our color. Then plug that in for the opacity. And we can see our texture appearing. But let's change the preview to be a plane, so that will be displayed correctly. And now you can see that. Hit apply, save, and we can close the material. The reason why we did that using parameters is that now we can just create a material instance and call it something like mi_decal2. Then you can double click to open that up. And in the lower right corner you can change the preview back to a plane. Then we can check the parameters, for example the texture, and just exchange that without having to duplicate our material. Also we can increase the emissive amount if we want to, or change the color, just like that, hit OK. So that way you can just very quickly create different versions of the material. But I would just use the m_goal decal for testing purposes, so that will do fine. Let's go to our blueprints folder, right click, create a new blueprint class of the type actor that we will call BP_goal decal. Then double click to open that up. Add a component, which will be a decal component. Select that, and we can choose our decal material. So m_goal decal. Also, we will modify the decal size. So let's uncheck the locker here. X will be something like, let's say, 70, and Y and Z will be 35. Another thing we want to do is rotate it in Y by -90 degrees, so it faces downwards. Otherwise your decal won't be displayed correctly. Then we will add another component, this time a box collision. And here we will also modify the extent. So X will be 75, Y can be 40, and Z 50. Just so it's approximately the size of our decal. Then we will add an onComponentBegin overlap event for our box, but we won't implement that yet. Instead, we'll add a variable called controller, and the type here will be skill player controller reference. Let's make that editable and expose on spawn. Compile, save, and that's it, what we can do in here for now. We will come in later. Let's close it for now. Instead, we will worry about the inputs now. So go to Edit, Project Settings, to the Input tab. And let's open up our action mappings. We can remove both the jump and reset VR. Don't need those. Instead, we'll add a new one called Enable Turn or Enable Turning, and we will assign the right mouse button to that. Then create another action mapping, which we will simply call left click. And obviously the left mouse button will be assigned to that. So select that. So let's collapse our categories here and close the engine inputs. Then let's go to our characters and the skill character. First, we can delete everything in the event graph here, as well as our two variables. Then we will head over to the viewport and adjust our camera boon. First, I will rename that to camera arm. It's just a preference of mine. So camera arm, then hit enter. And let's adjust the camera to be somewhere in between third person and top down, like it is common for MMORPGs. So we will uncheck use pawn control rotation, as well as the inherit pitch here on roll. Then increase the target arm length to, let's say, 650. And we will also rotate that in Y by -45 degree. Maybe that's a bit too much. Let's say -40 degree. That looks fine. Then we will hit compile, save, close our skill character, because all of the inputs will now be set up in our skill player controller. So we will open that in full blueprint editor. First things first, in our class defaults, we want to show mouse cursor. So check that. Enable click events and enable mouse over events. On event begin play, we want to get controlled pawn. Then cast that to the skill character. And if the cast is successful, we will promote that to a variable called controlled character. Or controlled char will do fine. So that's it for event begin play. We can remove event tick. And now we will create a variable called canTurn ? By default that will be set to false. Now let's implement our enable turning event, the input action. When it's pressed, just set canTurn to true, and if it's released, back to false. So that's everything we have to do for this. Then I will search for axis lookup and implement that. What we want to do here is first, we want to get our canTurn, connect that with an AND boolean, and check for can turn and whether the axis value unequals 0. Connect that to the end. Then we will add a branch and connect that to our input axis event. And if that's true, we want to get our control char, get the camera arm of that, and then set relative rotation. There it is. Now we need to figure out what the new rotation is. So let's do that. Let's move over the control char and camera arm. Then off of the camera arm, we want to get the relative transform of that. Search for get relative transform. Split that, and you will get location, rotation, and scale. We will only worry about the rotation there, so break that. Now we've got X, Y, and Z, also known as roll, pitch, and yaw. We will only worry about the pitch, and what we want to do with that is we want to add a float. And the float we will add is our axis value times float times float. Then type in 1.5. Just the value I found out worked fine when experimenting. Connect that to the add, and then we will clamp that value just so you cannot look through the map. And we will clamp it from a minimum of -40 to a maximum of 0. Then we will right click and make rotator. We will connect the roll and yaw from our break rotator before. Then the pitch that we just figured out and the yaw from before. Then connect it to the new rotation. And we've got that. Afterwards, let's search for input axis turn. And here we can copy over our branch, because we also want to check for unequal 0 and can turn. Connect the event to the branch, and we can copy over everything to the break transform from above. Off of the camera arm, set relative rotation. Then connect that to the true path of the branch. And off of the rotation, we want to break that. Then get the yaw and add float. This time what we will add is the axis value times 2 and connect that to the add node. Then we want to make rotator again. Connect the roll and pitch from before and the yaw we just calculated, then connect the return value to the new rotation. And that's it for our two events. Let's actually see whether that's working. So if we launch a new editor window, first you will see the different camera perspective. And if I just move the mouse, nothing happens. But when right clicking, we can turn around or up and down. Actually, I just noticed that the control for up and down is inversed. So we will fix that. To solve this little issue, just go to the project settings, input, axis mappings, and then expand the lookup. Here for the mouse Y, the scale set to -1. We will just remove the minus, set it to 1. And that should fix this little issue. Right, now it works just fine. And of course, if you want to have a reverse control, you can keep that. But I don't want to. Back in our graph, we will search for left click. Implement that. When it is pressed, we want to spawn actor from class. The class being our BP decal, whatever it's called. Controller will be a reference to self. And let's split the spawn transform. We have to worry about the location, and this will be our mouse location. So get hit result under cursor by channel. Channel being visibility, then break the hit result. And connect the location to the spawn transform location. The return value we want to promote to a variable that we can call something like current goal decal, something like that. Also create another variable called has movement command, question mark, or rather has mouse movement command. When we spawn the actor, we want to set that to true. and search for get a reference to self. Off of self, we will simple move to location, and the goal will be our mouse location that we already got to spawn our decal actor. Okay, compile, save. Also, we want to create a function called cancel movement command. In here, we will drag in our current goal decal, check for is valid. If it is valid, get the control char and stop movement immediately, character movement. After that, copy over the current goal decal and we will destroy actor. Then we will set has mouse movement command back to false and set our current goal decal to null. Technically, you don't need that because the actor is destroyed before, and because of that, next time it won't be valid again. But I think just for better readability and organization of your code, good to have that. Afterwards, we will return and also connect the returner to the is not valid. Compile, save, and back on our event graph, input action left click, we will call cancel movement command before spawning our goal decal. Then let's search for some empty space and go for axis move forward. Again, let's check that the axis value is not equal to 0. Add a branch for that, connect the condition, hook that up to the execution line. If it's true, we will get the has mouse movement command and add a branch for that. Connect that to the true. And if we have a mouse movement command, we will cancel that. Then drag in the control char and search for add movement input. Connect that to the cancel movement command as well as the false path of the second branch. For our scale value, we will just use the axis value. And then we will need to figure out the word direction. To do that, we want to drag off of the control char, get the camera arm, then get the relative transform again, break that, break the rotation into roll, pitch, and yaw, and then we want to make a rotator only with the Z, so the yaw, rest we will leave at 0, and then we can get the forward vector of this, connect that to the word direction, and that should do fine. So if we play, hit W or S, it will work. Perfect. Also, we want to move to left and right. So what we will do here is just select everything, copy and paste that, and search for input axis move right. Connect that to the branch and the axis value to the unequal 0 as well as to the scale force. The only thing we will need to modify is that we don't want to get the forward but the right vector, and connect that to the word direction instead. Okay, compile and save. Let's close it and go back to our BP goal decal. When we overlap something, we will get the other actor, search for equal, get the controller, and get the controlled char. So we check, was this the character that this equal was created for, then add a branch. And if our branch is true, we will copy over our controller and simply call cancel movement command. That way this decal actor will be destroyed. Alright, compile, save, close it, and before we can test, there is one thing left to do, which is to search for nav mesh bounce volume, drag that into our level, and we will scale that up. So let's check the log and set it to 20 maybe. That should be enough. Also select the nav mesh bounce volume, and if you hit P on your keyboard, you can see which areas are covered, so that looks fine. Save, and if we play, we can first see that the controls are working, so we can turn around and all look up and down. We can move with W, A, S, and D just fine, just like in the third person template. Turn around, up to the sides, everything alright. You can see the clamp that we created, so we cannot go higher than that. If we click somewhere, there will be a decal actor, and if we then click another location, the decal will be removed. Or we can click somewhere and then hit W, A, S, and D, so our decal will be destroyed. And the movement command will be cancelled, obviously. Alright, that's it for the second video of my skill system series. I hope you like it, and see you in the next episode.